Hey, this is Rubicon Ranger. Welcome back for another episode of One Take Triforcing. Today we're going to talk about last tick damage mechanics, as well as what I like to call Gambleforcing, which is just using the last tick mechanics to your advantage alongside statistical likelihood of something being destroyed to try and simplify your routing. We're also going to talk about a new mechanic we learned about recently that should be something that most people haven't heard of and might actually be super useful and make this not so much gamble forcing. So we're going to get right into it. Going back to something we talked about in my first video, which is just, normal damage spread. And by the way, if you haven't watched the first few episodes of One Take Triforcing, go back and watch through the series up to this point, or at least the first 2 or 3, so you can get what I'm talking about. So damage spreads out from one block to another set of blocks to all the adjacent connected blocks after the damage being done to the block has used up the health of the block, right? When damage gets to a point where all the blocks on the next step are over or have health over the damage that's being done, it cannot destroy all of them. In previous videos, I basically said it randomly picks blocks, and that's still true, but something that needs to be clarified, and we tested again recently just to be sure, is that it will always randomly pick one block on the next step of the blocks that it intends to use up. So say 4 blocks need to be used up out of the yellow, and then there's not enough leftover damage to destroy any of the 4 remaining blocks. What will happen is it will randomly select one of these 8 blocks, these 8 yellow blocks, if they're on that step, and it will completely use the health of it. And then after it's done that, it'll randomly select another block, use the health of that up, and then the next one, and then the next one. And then on the next step, it won't have enough damage to, destroy this next yellow block, and so it'll stop. So, knowing this, that it has to use up the health of the randomly selected block on the next step, you can kind of weight this to your advantage when you're routing things. So if there's a lot of components on the same that you could have on the same tick as one another, and maybe there's one vital component, that vital component is less likely to get hit. So just to kind of reinforce what we've been talking about here, if damage were to flow in from this red cube into this multi-connection rod, and it were to then go to these ghost modules, it would basically pick one of the ghost modules, since they're all in the same step as one another, and it would use up the health of it completely first before going to any of the others. Which means if one of these components was something that I wanted to be safe, it would basically have a 1 in 3 chance of being destroyed, or a 2/3 chance of surviving, and the odds increase the more you have. Now that doesn't account for if the other parts are removed. So if one of these has already been destroyed, then it's going to be a 50-50 chance of that part being destroyed. So what this would look like in a system with components that you have, if you have a lot of multi-connection components, and you already have sort of like a mini tick network in your bot already between the multi-connection components, because that's a nice thing to do for higher health efficiency. And if you have it in a block span build, usually you'll do a tick network between your multi-connection components, because damage can go up to one of the connections, flow into the part, and stop. And if it can't use all the health of the part up, and so there's a chance you can continue using that part, whereas single connection components, you just end up losing them. So if you have a tick network inside your bot, and you have some short connections, so my top and my middle mega hover here, and my middle and my bottom are joined by 2 ticks here and here, and then my top and my bottom are joined by 3. So there's a number of different things I can do here. For my middle hover, if I have another smaller hover over here, or some other single mount component, I could connect it to this middle hover by 2 ticks. Now keep in mind the mounting block is what's actually holding your hover up, so you're counting this as your step that you want to be safe, right? So there is a chance that this cube will get destroyed, but it's only if you have your 2 remaining mega hovers, it's a 1 in 3 chance, and then it becomes a 2 in 3 chance if you, or a 1 in 2 chance if you lose one of the mega hovers. The odds change slightly if you're using the lower hover, because now you have a 3 tick connection to top, and so this is still gambling, but in this case, it's a safe connection so long as you still have your middle hover. So if you have your middle hover, then your damage is always going to go to the center hover first before it destroys the mounting point of your single connection part here. And then there's a 50-50 chance, basically, if this center hover is destroyed, of damage flowing to your hover or your hover mount here. And a totally safe connections, of course, would be 4 ticks, right? Damage will always go to your 2 other hovers before it goes to your other hover. So this seems like, so why would you want to do this? Why would you want to make it, why would you want to have a system where you've purposely made it so that sometimes there's a chance that your vital components will get destroyed early? Well, you save cost, and you might say, oh, it's only one CPU, right? Well, if I go over to another system here, I can show you how that can add up very quickly. So in a tick network, and I've got a really simple setup here. You basically have different lengths of ticks between various components, and they go in order of your lowest to highest priority. So you have your your lower priority components on shorter connections to one another, and your higher priority components on longer connections to one another. So just kind of focusing on a network surrounding this disk shield module, and it's very simple. There's only a couple connections here. We've got a couple different things here. We've got my wing, we've got a propeller, so a movement enhancer. It'll give you speed boost and generate some force to help you get up to speed faster when you're moving around. And then you've got a damage sink. You've got your 2 mega plates or whatever multi-connection component that isn't as important or is purposefully used to shield against damage, right? So in this case, my disk shield module is syncing to my bottom mega plate on 2 ticks. My mega plates are syncing to one another on 1, and then I've got a connection to my propeller on 3. So this is an order of importance. So personally, in my personal building opinion, I am going to want my mega plates to sync to one another first. So if one of these mega plates gets damaged, it's going to flow to the other mega plate before it goes to my disk shield module. And if my disk shield module gets hit directly, it's going to go to the mega plate before it goes to any of my other components, because they're more important than the disk shield module, or they're more important than the mega plate. And then after that, I've got my movement enhancement modifier, whatever you want to call it, my propeller, and I'm making this, I have this as a less important connection than my wing because it will enhance your speed, but it's not something that's going to keep you stable and in control, whereas a wing or an active movement part is more likely to give you stability and control over your movement. And so if you lose this before you lose your propeller, you're in big trouble because you'll basically lose control of your bot. You won't be able to fly anywhere anymore if you just have wings or something like that. So, and then finally, my hover, which is, you could argue and say it's just about as important as the wing, but it's only got a single connection point. And so, there's a chance that, so if you were to consider that the wing and the hover are equal importance, there's a chance that damage can flow up into this wing, use a little bit of the wing's health, and then the wing will be left over. The hover, that's not the case. If this mounting point is destroyed and the hover's health isn't totally consumed, all the rest of its health is basically lost as, irrecoverable health. You get critted out then, right? So you want to preserve this hover for as long as possible. So this is the system that I have right now. And of course you can see that as always. And then also to illustrate, I've got a strut here on the bottom mega plate to illustrate that you can have other components coming off this mega plate, and their health has to be consumed before it goes to the other components. So, say you want to save some cost. Well, let's go over here. So what's happened in my system is I've removed 1 tick from the connection in between my disk shield module and the bottom mega plate. And at first you might say, oh, that's not really smart. Your plate-to-plate connection is also only 1 tick. And that's true. But I've also got my struts over here. So my disk shield is on 1 tick from my plate, and if damage flows out of this plate, it's basically a 50-50 chance that it's going to go to the mega shield or the disk shield module. And with my strut, it's only a 1 in 3 chance. Or it will always use the health of this first strut as well. So it's going to have to use the health of 2 blocks in this strut. And then on the next step, now what I've done is I've added all these other struts here. And so this has changed the odds. So now my dish shield is only a 1 in 5 chance of being destroyed early, because the damage has to pick between these outside struts, this mega plate, and the dish shield module. And so it's very unlikely that the dish shield module is going to get destroyed early. Now, of course, if I'm missing my mega plate or a couple of struts, those odds are going to become more poor. But the dish shield module is a fairly high health item, so there's a chance that the damage will flow into it, and if it's not enough to actually destroy that dish shield module, the dish shield module will be preserved, albeit missing a fair amount of health. So the next time it gets hit, it's going to be in a bad shape. But we've saved some cost. And now every single other connection can be reduced by 1 block. So now my dish shield module syncs to my shield on 2 ticks, 1, 2, and it syncs to my wing on, or my propeller on 3, wing on 4, and then also here what I've done is, since there's already so many other things connected to my dish shield module, I also have my hover on 3. And so this is an additional reduction. So the dish shield module has 2 other places that it can dump to before that are basically make this a safe connection. And then beyond that, I've got my wing connected on 3, and so there's a 50-50 chance that some of the damage is going to go into this wing if these other 2 sinks are missing. And the wing can take some damage, right? So there's a 50-50 chance that the wing will take some damage and it will preserve the hover mount. So I've further reduced the system by 1 block. So in total, I've saved 5 CPU. And you might say, again, that's not very much. I can't even buy another hover with that kind of cash, right? That's not a lot of CPU, right? Well, now you talk about a whole system. If you have a tick delay network, like a pure tick network bot, if you can do this in that, and you can remove 1 tick somewhere, down the chain between your less important components, you can reduce the cost of the ticks all the way up the system. You basically save 1 CPU for every connection on top of that connection, or with a higher importance, higher priority than that tick connection. So you can save a lot doing this, and you can make systems that are, yeah, there's a chance that you'll get modes that are not as good, but say you can afford another weapon or another movement part for more stability, then it can become worth it. And you can make things that normally wouldn't necessarily even be possible to make due to the cost of them. You can make them, and you can make them decently viable still. So let's look at this in a slightly more practical setup, but it's very limited, right? So here I've got another example of what you might do knowing what we've just talked about. So I've got a couple wheels here. This is just a kind of a car wheelbase setup. And I've seen Cataphat do this in the past, and I think I even mentioned it in one of my previous videos, but I'm coming back to it because it's something that he did that I thought was kind of neat. Right, so in this case, we've basically got 3 wheels mounted on block connections that we want to preserve. We've got dual mounts going out to our body, which is our common ground, kind of, for everything. It's going to basically a block spam body, and if you've listened to the earlier videos, this is dual mount, so damage has to flow out of here and use up blocks at a higher rate for, the number of ticks into here. You have to use exponentially more on the body side. Most people watching this have already know that. So this is basically a safe connection to the body. And same thing here. And then same thing, our body connection here is right here. I should probably have that colored gray. There we go. So there's our body connection there. And well, I think all these are also body connections. These ones on yellow here. So the wheels, basically all these wheels are already dual mounted. What more could you want? Well, we've got an additional split set in here. And previously we talked about integrated split sets. So these are integrated split sets, but instead of being connected to the block that the wheel's connected to, they're offset by one block. So when damage comes up this line from the body, for instance, and it flows up towards the wheel, on the step, so once this mounting block is destroyed, you've lost your wheel. But you don't have to lose your split set, because now there's a 50-50 chance that your wheel and your block will be destroyed. So half the time, if this block is still here and this wheel is still here and damage comes up through here, your block that the split set's connected to will be preserved, and the split set will be held up by the other connection to the body here, and that goes to the other wheel, and we have much the same setup here. And now keep in mind, so also what I've done here is, there's ticks in the split set, so that if damage hits this wheel directly, it'll dump out through the dual mount to the body, because this is far fewer ticks than this connection between wheels, and it's more likely to preserve our other wheel, right? And I've got the same thing happening here with my, this is like going to be one half of a bot, so right, you can have the other half of a car on the other side of this. And this would be a wheel, this would be a side-to-side connection instead of a front-to-back connection. This is another integrated split set, same story. It's offset by one block. And furthermore, damage coming in through any of these ports is going to go into the wheel anyway before it goes up these split sets. So nice little practical example. So there's lots of different ways you can use this. Always maybe don't use this too much, but in a few spare cases where you either have like an extremely tight design, or if you have something that is just needing to save a couple CPU to get one more part in it, you can do this sort of thing. And ideally for less important components, that's fine, especially if they're multi-connection. I wouldn't worry as much about it, because there's still a chance those parts can take some damage and survive. So what does this look like in a practical build? When have you ever seen an experienced builder use this? Well, I'll show you. So one of my clanmates, Razor Cabbage, we traded builds a while back. I built something for him and he built something for me. So he made this, which is a hover drone, a filthy hover drone, as many would call it, because, it's kind of a alternate form of flight using propellers and low mass. But what he's done here, since it's a very, very small, low-profile build with low volume and thus not a lot of room for routing, he's made a very choice decision here. And we'll actually come back to this later, but because there's something else going on here, and that makes it work better than you would think it would. And that's the unintended mechanic that I mentioned earlier on, or the new mechanic that we have to talk about at the end of this video, so stick around for just a little while longer. But what he's got here is he's got a connection directly from module to module and module to gun. And at first you'd say this is a bad idea, and it is. These are all three of these components are components that you would want to preserve for as long as possible. But there's a couple reasons why he chose to do this. One, the modules are very close to one another, and so it's easier to surround them with material that's less important. Two, he now gets a safe connection coming off of this module. So guaranteed, it's always going to have to use up some of the health of the disk shield module before it gets to the mounting point of this hover. And it's also, if you get hit in the disk shield module earlier, or if you get hit in the weapon energy, earlier, it's got a 50-50 split in between the gun and the blink. And since they're all very high health components, the chances that the second component will be destroyed by overflow damage is much lower. You'd basically have to hit it. It'd have to take some damage and then get hit directly with a mega rail that has no backstop, so no extra material behind it to hit, and then it resulting in all 3 out of 3 rail shots basically hitting it, the split individual instant 3 hit of the rail shot, right? So it's advantageous for this reason, and it allows them to simplify routing around the modules and the order of it. Also, when you think about how the weapon works with the modules, so he's only got one weapon. I only have one Mega SMG on this bot, and the modules are fairly low profile, and you basically have to lose the whole front of the bot before damage gets to the module. And if the gun is shot off, you no longer need the energy module, and the energy module is between the blink module and the gun. So the gun has to dump to the energy module, but by the time the gun is missing, any damage overflow, you don't really have much of a problem with it going to the energy module, because more energy is not going to help you anymore because you don't have a gun anymore. And then you use your dish module, shield module or your blink module to escape. So kind of a neat little compact setup and an example of actually, using this technique in a practical build. And this bot works. It just works. So now, yeah, sure, it's gotten me killed a couple of times, right? So damage could hypothetically hit this module, go into the blink early, and result in it getting removed a little earlier than it should. So now let's talk about what I was mentioning earlier. There's a new mechanic that we learned about, and we're going to talk about it here. And this is the part of the video that you really want to stick around for, because even if you've been around for a while, you may not know this one. So it turns out that the first connection of a part, or the connection that you use to place the component, has priority in certain situations. In this case, this is a very specific situation. So the rules are the damage has to strike the component directly, and if there's two parts attached to it on the same tick delay, or the same number of steps, the one that's attached to the primary mount of the component, or the mount that you use to place the part, will get the damage first if there's the same ticks between them. And I know a lot of people aren't going to believe me, and I didn't believe it at first either. And just for to give some credit here, Guy-Hor was the one, my clanmate Guy-Hor is the one who initially discovered this. They were actually testing a mortar, and there was basically two connections between two components, and it was always going to one component and not the other component. So what does this mean, right? So if you have a large component that's likely to take a large second burst of damage, for say like you have to shoot a mortar twice with a mega rail to take it off. First shot does a majority of its health, and the second shot will take it off, and then a massive amount of damage ends up flowing out of the part. So here we have two different scenarios. On the left side, the mortar has the dish shield module on the primary mount, or the center mount. And on the right side, the dish shield module is on one of the other mounts, and the leg here, which is going to be my sink in this case, is connected on two ticks to the primary mount. So what I'm saying is that if this leg is still here and this dish shield module is here, and a massive amount of damage overflows from this mortar, on the left-hand side, you're going to always see the dish shield module be destroyed first, or it's going to always take damage first before the leg. And on the right-hand side, the leg will always take damage before the dish shield module. Now, there's a few things that messes with this, and we've done fairly extensive testing, but we haven't done exhaustive testing. One is if you repaint the whole bot. So if I were to set this up and then use the right-click to repaint the whole bot, you will lose this effect. And I think the same goes for, I don't know if copying the bay will do it, but we haven't tested that yet. But things that don't affect it are respawning. So if you respawn, you don't lose this effect. This mechanic still works even after your first death. And the reason why I specifically mention this is because there's some mechanics like this in the game that go away after the first death. Like you have too many tank tracks and you get speed boost from them. And after, I think over like 5 or 6 tank tracks, I think it's above 7 tank tracks, you actually lose the speed boost of the remaining tank tracks after you die. So, and this goes for anything. We checked it out. Now keep in mind, in order for this to work, damage has to directly strike the part and flow out of the part, right? So damage flowing up into this mortar from somewhere else, so if I have a line over here, if damage were to flow up into here and then flow out to these other components, it doesn't work. The damage has to strike the component directly, so it's fairly limited in its application. It's mostly going to be for larger components that are more likely to get struck directly. You could go into your build and optimize it by placing every part facing a less important direction, but that's a lot of work, so up to you. So another example would be this strut. If I place it like this, then damage will always go to the red cube first before the green. if there's damage being split on the same step. And it's the same thing for this module. If I were to place it here, and if it were on the same tick as the leg, if damage were to strike this module directly, it will always go to the mortar first. If I place it down like this, it's always going to go to the leg first if it's splitting damage on the same step. And this goes for cubes. And those of you, I could use a whole cube here, and it would have the same effect, right? So damage goes to here. But I'm using an inner because that's funny, and some of you may know why. But this is very much like that, but much less powerful. And this goes for any cube. So if I were to put, like I said, a solid cube here, and damage were to be splitting in between all these green cubes in the red on like a last step, it will always, if it struck this cube, it will always go to the red cube first before the green. Alrighty, I'm going to actually do one more thing. I'm going to break the tradition of one-take Triforcing. I'm going to have one clip at the end here where I explain. I'm going to do a proof video of me testing this with Guihor when we first discovered it. But other than that, the episode's over, so see you in just a second, and enjoy. Alright, I'm going to have to talk over this portion of the video because I forgot to record audio at the time. But what's essentially happening here is we've got a couple different tests set up on this same bot. The strut between the mortars is set up with the primary connection facing left into the red EMP, and on the right the white EMP is on the safe side. So shooting the strut will always dump into the red EMP first and destroy it. And you'll see here that in shooting at it, you will almost, pretty much every time the red EMP comes off. And you can test this yourself, of course. So I'm going to try my best to shoot the middle strut in just a second here. And I hit it, and you can see the left EMP came off. And then I miss a bunch of times because rail lock is goofy. There we go, hit it again. And you're seeing that pretty much every time that left EMP is coming off, and they're on the exact same tick to one another. So normally it would be 50-50, but not in this case. And we're just doing it a bunch of times to make absolutely sure. And here I'm just going to zoom in so you can see that indeed, this is the mortar mounts. So on the left we've got kind of the same thing going on with the center mortar mounts going to the red EMP, and the right, on the right side the center mortar mounts going to the leg first. And so I'm going to shoot at the left one, and you're going to see that the left EMP gets destroyed. And the right EMP, if we shoot the mortar, it will sink into the leg instead of the EMP. And you see it's preserved. And same thing with the left, it gets taken off. And we're going to check one more time. And it's pretty consistent. We tested it a bunch, and we tested it after respawn, and a whole bunch of different things. So it seems to work as long as you don't repaint your bot. Certain other bay edits may also do it, like if you buy it off the shop, it may not work, but otherwise it works.